Okay, so you should be working on the Trig graphing worksheet letter A. That should be done, but I wanted to go through a couple of examples of it since we haven't had an opportunity to get it together since you've received it. The first one I want to look at is number 9. Number 9, let's just kind of review. The amplitude, remember, is always this number out front. And the amplitude tells us how high or low it goes from the midline. And since the number is negative 10, I need to make sure I pay attention to that and only give a positive 10 as my result, since amplitude is a distance, so a positive 10. Okay, next let's go ahead and look and see if there is a vertical shift. If there is something out here, we call that D, that would be a vertical shift. And that means that the midline that we have here would be shifted up or down based on the number that is right there in that space. There is not one, so what I'm going to indicate is that there is no vertical shift, or I can write the word none. The period is going to be 2 pi or 360 divided by the number out front of the theta or the x. And in this case it's 1. Because these instructions ask us to work with radians, we're going to go ahead and take 2 pi, since one full cycle of sine is 2 pi radians, and we will divide it by that frequency of 1, giving us a period of 2 pi. So one cycle of this sine function will be completed in 2 pi radians. The phase shift is going to be the opposite of this here. And we're going to talk a little bit more about that in our next example. But the phase shift in this case is negative pi over 4. Essentially, it's what makes what's inside the parentheses equal to 0. So we have our phase shift of negative pi over 4, our period of 2 pi. If I went ahead and made my 4 notches, the first one would be pi over 2, and then pi, 3 pi over 2, and then 2 pi. That would be one full cycle of this particular sine graph. What I know is that the entire graph is going to be moved to the left pi over 4. So I'm going to go ahead and I'm going to kind of make marks here, because if this is 1/2 pi, then halfway between there is pi over 4. And so each one of these notches now is worth pi over 4. So I've kind of broken it down a little bit. My original sine graph is going to start in the middle, and normally would go up, middle, down, middle. But because this sine graph is negative, I need to do the opposite. So the original sine graph would be middle, and now this case down, middle, up, and then middle. And how high up does it go? It goes up as high as 10 and as low as negative 10. Now this is the original sine graph, but it's been flipped upside down. I also know that each one of these points needs to be shifted to the left pi over 4. So I'm going to go ahead and take each one of these and move them to the left pi over 4. So one particular space, they are moving. And you can do this however you like. I'm actually moving the dots. You could have started just pi over 4 to the left. And then you go ahead and swoop through, making one full cycle. This is one full cycle. I do know that the remaining sine graph would continue. I'm just asking you to draw one cycle. Okay, number 3 is the one I told you to skip. I want you to look at that one. Number 3 is fairly straightforward in terms of the amplitude. That's going to be 1/2. It's the number up front, the positive version. And out here, there is no number, so there's no vertical shift. The number in front of x is 2. It looks like we're using radians because I see the pi symbol there. So I'm going to take 2 pi divided by that number out front, and I get a period of pi. were to graph this, one full cycle of cosine would be done after 1 pi. The phase shift in this case, I don't know if you noticed this, but this one looks different than our notes. In our notes, we had something like cosine of b parentheses x minus c. So that b that's in front of the x was separated out. It's not separated in this case. And so if you wanted to, you could rewrite this as 1/2 cosine and take that 2 out of the x and take the 2 out of the pi. So dividing this by 2 would give me x. And dividing this by 2 would give me minus pi over 2. That is one way to figure out the phase shift, by actually factoring out the number that's in front of the x. Another way that people tend to do this is they go ahead and they take what's inside the parentheses, 2x minus pi, and they set it equal to 0. Because our phase shift will be whatever x value I could plug in to make that equal to 0. So if I took what's inside the parentheses and set it equal to 0 and solved for x, 2x equals pi, divide by 2, x equals a positive pi over 2, and that is my phase shift. I could have, again, either found it doing what I just did, by going ahead and solving, or I could have found it by factoring out the 2 and taking the opposite of what's inside the parentheses. Okay, so you have completed the worksheet A at this point, and your assignment over the next 2 days is to go ahead and complete the worksheet B. It has a few more problems on it, which is why you're being given 2 days to do it. And I want to go through one problem from that worksheet right now. Okay, so worksheet B, I want to start by looking at number 7. I wanted to do this one just to get you started on worksheet B, so you can kind of remember all of the processes for this. If you notice, number 7 has an amplitude of 4. Do that. Remember, it's a positive number because it's a distance. There is no vertical shift. The period, this looks like it's being we're using degrees, so we're going to take 360, since that's one period of sine, divided by 3, and that gives me a period of 120 degrees. Let's go ahead and use that method where we set what's inside the parentheses equal to 0 to find out what our phase shift is. So adding 90, I get that 3x is 90, and dividing by 3 gives me that x is a positive 30. Our phase shift is positive 30. Okay, so I know that I'm going to go out 4 notches. And on this 4th notch, that will be 120 degrees, because one full cycle of this particular sine graph is going to be 120 degrees, one period. If I cut this into fourths, this is 30, 60, and 90 degrees. I also notice that this particular graph is going to be shifted to the right 30 more degrees, so I'm going to extend this out 150 degrees to 150 degrees. Okay, this is a sine graph. It has an amplitude of 4, so I'm going to go up to 4, down to -4. And this sine graph normally starts off in the middle and goes up, but because of this negative here, this is going to start off middle and go bottom, middle, top, and middle. This is what it would look like without the phase shift. Because this is moving to the right 30 degrees, I take each one of these points and move them 1 notch to the right. And then I go ahead and draw the curve. And again, it would continue, I just am not asking you to. All right, dive into that worksheet B, the graphing worksheet B. see how far you can get, and I have a couple more examples for you for tomorrow.